When Stace told me I can do that.
Well, we got some people in, got a few people in, so that's okay. Okay, hi everyone. Thanks for coming along this afternoon and taking time out of your day to join us here for an afternoon of automation with Deloitte and Red Hat here. Thank you very much to our friends at Red Hat for joining along and coming in and helping us present this. Really appreciate it. Take your time. I know this is a lot of work doing this sort of thing, so really appreciate it. Before we kick things off and get into all the discussion around automation, I just want to talk about a bit about the higher level DevOps stuff. And it just occurred to me that I didn't even introduce myself. So rewinding once again, hi there, my name is Everett Taves. I'm a platform engineer here at Deloitte, hosting this little event with Red Hat that I've already talked a bit about, an afternoon of automation. Okay, so talking a bit about DevOps and some of those higher level principles that we're trying to get after, even when it comes to doing all of this automation, right? So we've got all this wonderful tooling and stuff, but what are kind of some of the higher level principles that we want to address with this stuff? And I'll take us through this stuff pretty quickly so that we can get down to the fun bits, the technical bits, and get into that stuff. So I consider DevOps to be, very much kind of an umbrella term. It doesn't have any one specific definition. It applies to a lot of different facets of software engineering and system administration and security and a lot of other things as well. And it does really mean a lot of things to a lot of different people. So I'll try to give it a little bit of form here. And I have the one particular definition that I like, the COMS definition, and we'll get into that. And it's kind of one of those terms that's like agile. It means a lot of things to a lot of people, but we'll make it fit for our purpose, right? So what is not DevOps? What it is not. It's not just throwing developers and operations together and just kind of like smashing them together and hoping good things happen. It requires a little more thought and effort around that. It's not a team. You don't have a DevOps team. It's actually a set of principles that you apply across your entire business. And very much including the business people and the things that are actually driving the work you're doing and the value you're delivering. It's not a job title really either, much as the same as it's not a team. We have slide. There we go. Yeah. Hi there, welcome. Thanks. And yeah, always lots of seats at the front. Yeah. DevOps is not just about the tooling and the automation, and I'll touch on that a bit more talking later on the automation, because a lot of the times the automation and tooling wind up taking up all the oxygen in the room, and there's nothing left to talk about, which is why I'm doing this little spiel first. So what is it really about? It's about that flow, about getting value to your customers and removing any waste in that process. It's about getting feedback from your customers and incorporating that feedback into your products and services, and continually learning and experimenting the whole time through, the whole way through that. So I'm going to use the COMS definition, culture, automation, lean. I throw in another L in there, learning and experimentation as well, measurement and sharing. There's also a new movement, I guess, whatever you want to call it, DevSecOps, where they're like, oh, we kind of forgot about security and the whole DevOps movement when that thing kind of kicked off. Like, whoops, now they're kind of coming back and backfilling in a lot of the security bits with this DevSecOps business. But it is something that should be built in to everything we do across the value chain as we deliver software to our customers. Okay, so culture, starting with the C quickly here. I particularly like this picture with regards to culture, the Petri dish. There is some Petri dish business kind of going on, a little bit of science in there and experimenting with things, putting people together and seeing what comes out of it. And you're never really sure at the outset what is going to be the right configuration, what the right teams are going to be, the right combination of people in order to get that kind of growth that you're looking for. And this is the kind of growth that I'm looking for. I collect spores, molds, and fungus. So this stuff is a dream to me. And it's having that culture where, you're not just doing waterfall. I still see lots of places that are still kind of in a very waterfallish mode. A lot of upfront design and stuff. You want to really get to that place where you're doing just enough design in time with your sprints in a much more agile method. And you want to kind of start moving away from project-based funding and things like that, and more considering everything in your stack as products. Infrastructure isn't just a series of projects. You can consider your infrastructure as a product that helps deliver value to your customers. Then there's the automation, which is really why we're all here today. We're talking about the tooling, the technical bits, all the really cool bits and pieces that go into making this stuff work. The pipelines, all the different automation tooling like Salt or Chef or Ansible or what have you, or Puppet. Jenkins for pipelines, there's Bamboo, there's TeamCity, there's all this kinds of tooling. But a lot of it boils down to treating your infrastructure as code in various different ways. And a lot of those tools deliver that sort of stuff. Now you have pipelines as code, and we're just getting more and more stuff into source control, which is where it should be. So it's all very apparent what the current state of your infrastructure is at any given time, and you can manage it going forward much more easily when it's in source control. And of course, there's with the advent of cloud and now containers moving to the forefront, these things are all coming with APIs, so they're all becoming much more easy to automate. And then lean, talk about just a little bit here. This is all about delivering value quickly to your customers. I consider then like having a minimum viable product to get out to your customers. I think minimum viable product is just one part of it. I actually wind up talking a lot more about minimum viable process, and that speaks towards your value stream. There's oftentimes like a lot of barriers between you and actually delivering value to your customer, actually shipping software and getting something in their hands. And sometimes it's a matter of bringing it back to the culture and finding ways to reduce the process and getting people to understand that maybe we don't need all this process. Let's see what minimal amount of process we can get away with, and removing waste and toil from that value stream. So you're just so you're shipping code as quickly as you can to your customers. I should have used the code shipping squirrel here if you've ever seen it before. So this is the extra L in the Combs definition, learning, and I'm throwing in experimentation as well. I'm a huge proponent of deliberate learning. Like on-the-job learning stuff is great, and we all do it. It's just natural. You get thrown into something new and you start picking it up. That's all well and good. But there should also be room for deliberate learning as well. And that's something that's on all of us to kind of push for wherever it is we're working, taking that time to get a deeper view of the things we're using, rather than just kind of just knowing the little bits and pieces that you touch on, and then getting away with that. One thing that I've really helped me a lot was I took a Coursera course, Learning How to Learn, which is really cool. And it helps you understand a bit more about how people actually learn and the process that they go through of chunking together information. It's a lot of theory in there, but I found it really interesting. And just like get started and start experimenting. Like sometimes I so often have to tell myself, like, stop reading the damn documentation and just start doing something and making things break and learning from that. Because too often I find myself going down a documentation rabbit hole when I should just be getting my hands on the keyboard and making things happen. Measurement, this is everything from monitoring with logging and metrics, getting that observability into your systems that you need to understand to help you troubleshoot, debug, optimize. It comes a little bit later in all of this, but it is the kind of thing you need to have from the get-go as well. Shipping off your logs and metrics, to whatever it is that you're using, Elk, Elasticsearch and Log/Kibana, or Splunk or Datadog or any one of these tools, so you can understand your systems a lot better, and using things like distributed tracing to actually find out what your calls are, where your calls are going through your entire chain of microservices or whatever you're actually deploying out of production, so you can actually trace your call right from start to finish and understand what happens when things go wrong. And sharing, another kind of passion of mine, hence, sessions like these, but another big part of sharing I find is actually getting people together and staying on the same page. It's enormously difficult to do, but there's like a lot of collaboration tools nowadays that make it so much more simple. Like when it comes to docs and stuff, really kind of the gold standard to me is Google Docs. I'm always harping on everyone about Google Docs because you can literally see people typing in the same document at the same time. You all get together and you collaborate on something and it's all there in real time. It's so powerful rather than emailing a document around and including your initials and a version on the end. What I should have done here, actually, I should have had another slide with that communication path. When you add like yet another person to a team and you show the amount of communication lines it incurs, I can't remember if it's exponential or factorial or what, but you add so many more communication paths when you add a person to a team. But if you're using kind of these same page comm tools like Google Docs or Slack for chat, where everybody's all in the same channel and they can see everything that everyone's doing, and you can have chat bots in there, or video conferencing, regularly, actually, and using the video in video conferencing. I've been surprised to see how little video is used in video conferencing lately. You actually see people's faces and their reactions. There's a lot of body language when you're talking to people. That's what makes in-person contact so great.
That's a question.
Shoot.
How many of you automatically default to turning the video on in a video conference session?
I used to.
Yeah, most of us don't. And yet, if you start making your default behavior, you'll suddenly find your meetings become shorter, become more concise, you can interact better. It makes a huge difference.
So yeah, I like it. I like it a lot. The question there was, who defaults to actually turning their video on for video conferencing, and well, really nobody put their hand up. And so it's a matter of, it's all on us to change these defaults. We'll have better meetings and we'll have better interactions with our colleagues. I like it a lot. And then, yeah, so it's probably not as applicable here, but there's like a lot of great, there's been a lot of great writing on remote work lately. GitLab has this really great remote manifesto on how to do remote work with your colleagues in other locations. And there's a lot of really valuable stuff there. And coming out and presenting your findings to your colleagues, whether it's at conferences or meetups or just within your companies, or even within your teams, like demoing at the end of a sprint, things of that nature, all really, really valuable stuff when it comes to sharing knowledge. And the obvious segue here, right, is we're sharing knowledge today, right? So we've got Red Hat here with us to demonstrate some technologies around automation. So now we can get back to the cool technical bits and get away from all this blah, 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 and see some code and see some demos. So without further ado, Mandy, would you like to introduce yourself a bit here? I'll let you get in front of the camera here, and you can.
So how far do we have? We have to. No.
Oh, to that partition there.
To that partition. Yeah. Okay, cool. Okay, cool. So I'm Mandy. I'm a solution architect with Red Hat, and I'm based in Auckland. Please don't hold it against me. And I am going to talk about automation on Openshift. So Openshift's kind of quickly becoming my specialist subject. Who's heard of Openshift before? Cool. So I do have a couple of slides on Openshift 101 for those people who haven't seen it or heard about it before. But the focus is really about automation and various kind of layers of automation. I have a heap of little snippets of demos to show you, which is cool. Does mean something's going to break, I am sure, right? So bear with me if that happens, because in the more we're talking about lessons and learning and just doing stuff and learning from mistakes, right? So let me just bring up my slides. I have to do a quick change of the video monitoring style as well. Just one moment. displays, range, oops, no one, mirror. So I'm going to do mirroring because I have to show you so many demos and I need to do the code here. So all right, cool. So few little bits about OpenShift to start with. So containers and Kubernetes, that's what OpenShift is all about. So who's doing containers? Yep. Who's doing Kubernetes yet? Yeah. Okay. So containers. We all know. We've all heard the DevOps talk. We're all on that, so we all know why we're doing containers. But of course, containers by themselves are not really enough. This is my one and only iceberg picture in my slide deck. And to do containers properly, you need a whole bunch of other stuff, which then is hard, right? So doing containers in production is not easy. And all of this stuff underneath the iceberg, in particular orchestration, is what you need to productionize your containers. In our case for orchestration, we are using Kubernetes, which is an open source project from Google, of course, and we are tightly built. OpenShift is our platform that is tightly wrapped around Kubernetes as an orchestration tool.
And just before you move on there,
yeah,
I think it's worthwhile to point out, like, obviously, it's just more than just containers. You need all of that stuff.
That's
no
correct.
matter what you're doing. It's just, it seems like containers have, I don't know, for whatever reason, brought a lot of it to the forefront.
And I think people kind of go, oh, I do this container thing, everything's isolated, everything's wrapped up all in my container, and I put it in production, and magic happens, right?
I'll rub some containers on it.
Yeah.
And it'll all be good.
That's right, exactly. So, you know, building a container is not that hard, but actually then, you know, running it for production is. So we talk about this kind of enterprise architecture for Kubernetes and all the layers that you need to build upon to really have an enterprise orchestration platform for containers. Now, obviously, there's a lot of red on here because, you know, I'm from Red Hat, so we're talking about Red Hat technology, obviously. But the two kind of sides to what we see that's really needed to support the whole DevOps, the whole Agile, all of the, you know, the movements today is you need a good developer experience and you need a good operations experience. And so from an operations side, it's not just about the infrastructure underneath, but importantly, you know, your infrastructure needs to be able to run anywhere. So whatever cloud, laptop, wherever you want to run that. But operations need to be able to manage those platforms too. They need the automation tools, not only to build the infrastructure. So Stephen's going to talk about Ansible later on as a tool for automating a lot of your infrastructure builds. But they also need, because they're now running a lot of these containers, these applications that have been handed, they're still being managed by someone, if you're in a DevOps team and you're slightly more on the ops side, or whether you're just a traditional ops team as well. You need a good tooling that helps you automate those processes. And from a developer point of view, you need a really good experience on Kubernetes to make life easy for you. And our tool around that is OpenShift. This is not a sales pitch about OpenShift, but I'm going to show you some things on OpenShift specifically around automation. So where we look at looking at automation as a way that actually helps developer productivity. So people who know OpenShift, you're familiar with this slide before. This side's really your dev focus, that side's really your operational focus. And it's really about making Kubernetes easy. And there's lots of people who have done lots of low-level stuff with containers and Kubernetes. And if you want to get to that level and you want to be that kind of 10x person, you still can be. But OpenShift provides that way of abstracting that up. I mean, that's what you have a container platform for, whether that's OpenShift or one of the other ones. So developer productivity, key thing, automation. Yeah, and pipelines, consistent environments. So consistent environments we get from containers, and self-service. I'm going to show you a few of those things today. Okay, so everything is code. So the three kind of layers of this: infrastructure as code. So being able to redeploy your infrastructure quickly or from a code file that's sitting in GitHub somewhere, that's repeatable every single time you deploy it, and that can take minutes, or rather than having to go and provision this in this system and that. Now, and Steve's going to talk about that a little bit later. Containers as code. So artifacts that you can, again, have in GitHub. That means that every single time you want to redeploy and rebuild your containers, they're the same, and you can build things up, run things up repeatably and faster. And pipelines as code. So I'm actually right in the middle of doing quite a big Openshift certification course at the moment. And one of the things the guy said at the moment is, if you get your pipelines right, you can make Openshift sing. And I really thought that was an awesome line. And at the very end, I'm actually going to show you a massive build, as long as I push the button and it works, of course, that I think really demonstrates how using a pipeline and using automation across all three layers of these really makes Openshift sing. So, demos. Okay, so a couple of things about my environments. And because I'm mirroring so that I can actually see what I'm typing on the screen, I will have to switch back and forward. So hopefully I won't trigger anyone's and everyone will be able to follow my screens. I'm using two environments today. One of them is an environment which is called the Red Hat demo system. And it is an environment that's deployed through a tooling called CloudForms. And it's fully automated. And so I'm going to show it to you, but I literally order an environment, and it's fully automated with a combination of Ansible and template files and everything living off GitHub. And that's the one I'm actually going to show you at the very end, where I built this big stack on OpenShift. The other thing about this is that this environment actually automatically tears down. So one of the things about developers, me included, is we're not very good at cleaning up after ourselves, right? So Amazon can become very expensive. We use, I heard a number that said Red Hat used to spend like $7 million a year with Amazon on all the environments we use. And I thought, wow, that sounds like a lot of money. And so I thought, actually, that's a year, that's globally, we have like 11,000 people worldwide. That's not a lot of money, because we use this for all of our demos, for all of our training. That's actually not a lot of money. So either someone told me the number wrong, or we're doing very well with how we're actually controlling those environments with tearing them down, etc. And it's all automated, right? So there's a timer that says at 6 p.m., those training environments all get torn down.
This isn't just provisioning VM.
Sorry?
Time zone, 6 p.m. which time zone?
Oh, with the time zone of where the training is. Actually, for those ones, yeah. So my one that I'm using, the demo system, has a day limit, and I can actually go into CloudForms and then say I want it for some extra days. Sure. So it's really good. And then my other environment that I'm using is just an Amazon environment. It's just a VM that I've got, and I'm using OC Cluster Up, which is a way of running OpenShift in a container. So it runs in a container on Linux. It's very, very easy, your easiest way to start OpenShift up, whereas this is actually a full cluster. This cluster that I'm running here is actually a multi-tenanted cluster. So I am a tenant on a global cluster. So everyone around the world uses that same cluster, and I'm just a single tenant on it. Right, so first thing I'm going to show you is about automating your builds with a kind of underlying technology called source to image. And it's, let me see the next one. Yeah, I'll show you this one. So essentially, when you're a developer, you want to write some code, check it into source control, and then you just want magic to happen. You'd like magic to happen, and your images and builds can be built and deployed onto your container platform, which in this case is OpenShift. So So we've written some code, checked it into GitHub, done whichever method. I'm going to use two methods today, command line and web interface, which will then automate the build for that. So what does it do? It reads the source code and says, what source code is this? Oh, in this case, I've got a PHP app. PHP, I'm going to go and get the base image from the Red Hat registry of PHP, and I'm going to use that. I'll get the latest one, and then it builds the layers on top. So whenever the image is built, you're always getting the latest version. So if there's any fixes or security fixes, etc., have been resolved, the security people. And then it will wrap all of the dependencies and etc. into my container, and then it will deploy that onto OpenShift. So I'm going to do that. The other way you can also do that if you have your own binary. So that's source code. Some people actually have their own WAR files or their own binaries that they've already built using some other tooling. So you can do the same thing there where you've built a binary, and then you can pass that into OpenShift, source to image, and it will automatically build that for you and deploy it. You can then also take a build that you've already done, a container that you've already built, and deploy that as well. So it's not just, oh, I have to do it from source code. You can actually do it from all those layers in between, and then OpenShift will just pick up. So whichever one works with your workflow or the kind of application you're using, or what's your processes in your organization, or in fact, what stage of development that you're in. Cool. Okay. So now I have to switch over. Any questions? Well, I just have to put glasses on too. All right. So my OpenShift environments. Okay, this one here is my RHPDS environment that I was talking to you about. And I'm just going to show you how I got that environment. So this is CloudForms, and we took that from a catalog of services that have all been set up. So every single one of these is an environment that has a set of automation behind it, Ansible, YAML, templates, etc. That when I go and order, so I'm just going to go to this one. So for example, this one here, CIDC for a monolithic application, I can push the order button, and I already have this one actually already in the system, push the order button, and automatically it will go back and build all of the elements that I need for it. So, and that there has given me this with all these projects. So this is the OpenShift interface. This is my OpenShift container platform that I have on Amazon, just on a standard VM that I've been running OC cluster up. As those people who use OpenShift, I assume that you've seen the OpenShift. This is 3.9. Okay. So those are, when we looked at that developer productivity, that really comes under the self-service as well. The ability to actually, I myself can just go and ask for an environment. I didn't have to ring up my trusty ops people, fill in a form or anything. So this one actually already has quite a few projects already in there because it's someone else's environment. I'm just borrowing for that. So I also have, this is my trusty version of automation as well, copy paste from my, just to make sure that I show you everything. Alrighty, so source to image, this one here. The first one I'm going to do is show you doing this via my Amazon environment. So if I go back to, so I'm going to, everything with OpenShift, do this in the back end. Everything with OpenShift has a command line or a web interface. They all work on top of an API. So every single thing that I can do in the web interface or on the command line all goes through the API, right? So I can control OpenShift completely with API. And that means that if you're really clever with curl or something like that, you could actually sit there and just write curl commands and can completely control your OpenShift environment using that. So
we're starting to see a lot of third-party IDEs integrate directly into OpenShift now. So your developer will literally go drag down, deploy, and everything in the background's taken care of through that API layer.
So I am just going to log in to this environment first. So this is my Amazon environment, and I'll get my login. Okay. So I have OC command liners running on my machine, and then I just log in straight to Amazon. Here we are, and I'm going to, is that big enough for everybody?
Yeah.
Cool. I'm going to use the command line to create a new project. I can also do this on the web interface as well. Okay. So now if I go to view all projects, I should now have a Mandy's demos. Okay. So the first thing I'm going to do is add a new application. I'm going to do it through the web UI, as I said. So these here are a bunch of base images. These can be a combination of a template, like this one here, which has 2 bits of technology that will be built as part from a template that's in source control, and I'll show you what those templates look like. And then also these ones that are just single base images. So in my case, I've got PHP. The template for this builder has been imported into Openshift as part of the default. So now as a developer, can go in and just fill in the variables.
So Mandy, how many of you have used Kubernetes at all, or understand it? Do any of you understand the principles of Kubernetes or some of its benefits? One of the big benefits of Kubernetes, other than giving you that wrapper to make the ability to deliver containerized workloads a lot simpler, is Kubernetes allows for like this namespace separation, so that multiple developers, multiple projects can actually share the same compute workloads but have isolated environments. So in effect here, Mandy's project is an isolated project. It's not going to interfere with the resources of another project. It has its own IP address space. Therefore, you can overcommit existing resources, existing infrastructure at a much higher level thanks to containerization, but also allow for parallelized development efforts. Every developer can have their own copy of the production stack because of that isolation that containerization and Kubernetes is providing. So it's taking care of an awful lot of heavy lifting. Historically, you'd have to go and require a network team to set up new networks and firewalls and rules and segregation and request new VMs. You don't have to worry about any of that. It's self-service, as Mandy said.
Yeah. So that has now built. So it has cloned the GitHub repository. I told it that I wanted PHP 5.6. So I got that base image, and then it has built all the layers of the container, and it has now deployed it. Because I did it through the web interface, it also gave me an added feature of giving me a route automatically. So routes are the way in which we connect into our application from the outside. And hey, there will be cats. I promise you, we will have cats as well. So this is just a simple PHP app that's like a voting system on vote for your favorite pet. All these pets were provided by Red Hat people. Oh look, there's a cat. But there is a version of this that has all cats, and I'm just going to cheat just a little bit here because I happen to know the URL for this one. That's the pet I provided, which was a little rescue hedgehog that I rescued and saved before I discovered that hedgehogs are really bad for our local native animals. So then I felt, then I was torn between saving its life and maybe it went off and ate some bird's eggs or something. Okay, so I am now going to do the same thing, but in this case, I'm going to do that from the interface. So I'm doing the exact same thing. I'm able to tell it what image I want, what base image I want, my GitHub, but in this case, I'm actually giving it a fork. So this is a branch, sorry. So my branch here, cities, is going to show cities instead of pets. So the same thing is happening with this one. The one difference between the automation that happens from the command line is that I won't get my route automatically. So that when I go in, I'll either have to manually do that here or I do that from the web interface. So, but it's done the exact same thing. So source to image is actually an open source project that you can use outside of OpenShift. And you can go and find it on GitHub. Cool, so now I have these two applications.
So what you're doing is inserting a little bit of stock data into your existing project so that it knows some information about how to build your project. After that point, you can automate this to your heart's content.
So this is the GitHub repo where all that's come from. Now, I could also use a template file that was in GitHub to do a build. I'm going to talk about templates next after I've shown you a couple of other things on here. Sorry, I'm going to have to, as I'm flipping through. Right, so I've got the two applications. This one didn't get a route, but that's really easy. I can easily do it on here, or I just go and create a route on the web interface. So I'll do that. My application cities, that looks good. Create. So now I have both these applications running, this one. And I'm going to use these two to show you automation for A/B deployments and Bluegreen deployments and using pipelines. So there we go, cities instead. If I can also scale up, scale down. Now, all of this can be included in your template file for when you actually deploy. So if you wanted to have this deployable from a template file that was in GitHub, you could set the replication number of pods that you want to run for each one, and that could also be different per environment. So for example, in my test environment, because I may need just 2 there just for testing, but in production I may already know that my performance I actually need 6 running. So those are things that you can do through your pipelines, and you can insert those variables as you go through the pipeline process. The build itself and the image of the code isn't changing. It's the resources that are wrapped around the deployment of that. So let's have a look at a couple of objects here. They're called Openshift objects that help control this. So this is the build config. And all of these, deployment config, sorry. I'm just going to go to my YAML file for this. So this is the deployment as code. So this is the deployment of my container as code. Now that could be built into my template file so that I can have this idea of everything sitting as code in a source repository. This kind of looks pretty crazy when you first look at it, but this is automatically generated. As a developer, you could use this to actually give you a base for a template. So you could actually use OpenShift to kind of get the deployment as you want using the interface, and then actually build your template file. And then the next time you built it, you could actually just run it from your template. So you didn't have to go through like the process I did. I created that route and I did some other things. You could bypass all that by just using the template. And I'm going to show you that in a different app. So this has all of the replication control. This is all to do with deployment. So the build and the deployment, as per like 12-factor app policy, should be separate, right? So this here is just all the configuration around my deployment. Now I have the same thing. If I go back to my builds here, go back to builds. I had the same thing in builds. So if I look here into this application, this is now my build config. So here I can, looking at the configuration this way, I can look into the YAML file again, and you can just have all of this as code. And this in the templates, which I will show you. If you look at this at the top here, build config. So there's a number of OpenShift objects that you can put into a template. Anything valid, any valid OpenShift object can go into a template. This one is a build config. If I'd highlighted the top one before, it would have been a deployment config. Make sense?
One concept that takes a little bit of getting used to when you first look at something like Openshift is that every time you run a build, it creates the containers required to build your image and then disposes of them. They've gone away. Then when you actually do the deployment of your code, the image you've created, you're deploying an immutable image every time you do it out of your image repository until you do the next build.
So if I just show you this web interface, that's what Stephen's talking about here. This My Application build, that was the builder container, that the pod that just spun up automatically when I did source to image. So source to image brings up lots of little containers to do jobs, such as build it, and then tears them down when necessary, so build and deploy, etc. So you can see those ones have already run and completed. And at the moment I have these ones. I have 2 applications running and one of cities. So if I think the other thing about automation too is that as a developer nowadays, especially depending on what your DevOps team is like, you have to be responsible for it in production as well. And so the ability to know that, so with a container, so this is my, I probably won't be able to do this fast enough for you to see, but if I delete this to simulate a failure, and I go, so I'm just going to delete that really quickly and jump over here, and it might restart. There we go. So it's in the process of restarting. So Openshift recognized it had died, and then it will automatically bring one up. And then it will go back down to 2. There we go. So it realized that my application had died, knows it has to have 2 all the time, it will bring that up. And the replication controller works out where that needs to go to be the right place. So you also don't have to worry about load balances and which VMs where they are or anything like that, because Openshift figures all that out by itself. So it works out, it will put it on a node that it can run that's healthy, that has enough space for it, etc. So we're also going to, I'm going to show you.
Just taking that bit further is that when we start looking at more complex workloads, customers now wanting to do complex data analytics using things like GPU offload, then we can tag certain parts of a compute farm as having available GPUs, and the scheduler will know that your workload is a special class of workload. It wants to grab a GPU that's doing AI analytics. It needs that kind of hardware, and it will be scheduled accordingly. So again, there's lots of really smart things under the hood that once you've set them, it's set and forget. The infrastructure will take care of it for you.
You can also put into your build and your deployment environment variables. So these are also an object that you can add in, which I'm going to add in here on the interface. And I'm going to, so I promised more cats, I'm going to update an environment variable called selector. Because I've made a change there, the system has, the configuration says automatically deploy this when a change to, this is just my deployment configuration. So it didn't need to rebuild my image. The image that's built is exactly the same. Deployment configuration has changed. So it's redeploying that app so that the new environment variables will get picked up. So now, if I go to what was pets, we should now find that it's just a bunch of cats. Oh, gotta have cat pictures, right? Oh, there is an Auckland cat in there, and there's a Wellington cat, I think, as well. I'll cheat, do Wellington. Hope there's a Wellington cat. Yay! Oh, very cute. Okay, enough of cats. So in this, now we have, it's the same Git repo, but one branch was my cities branch and one was my cats branch. Okay, move on to the next thing. Any questions? Cool. So deploying from code as well. So I was talking about templates. So you can put any valid object in there, and these are some examples of those objects. So build configuration, your services, which are your routes, secrets, which streams the images are coming from, your replication counts. You can even put pod controls in there as well. So what's my next? Okay. If you can build your templates from scratch. So think about doing them from like the bottom up. And I think I've got that on the next slide. When you look at the service catalog, that's actually a bunch of templates in there that have been preloaded. So you can build templates that you want your developers. So in your organization, there may be a specific template that you need. For example, that might be a C++ app, and you want developers to be able to have C++ as a base for what they're building on. So you could actually build that template and put it into your catalog. So the ones that you see on there are all just default ones that come. You can extend that with your own templates. And I'm not going to talk about them today, but we have there's also the service broker that we have, and you can build templates for the service broker, which can also go into the catalog. So you can see how by kind of coding up those base repeatable builds, and then it means that your developers, although they've got self-service, you also know that they're getting exactly the same. And as you move through environments as well, they're also exactly the same. And it just makes it a lot easier, right?
As a Red Hat customer, you get a very broad range of technologies ready to use in containerized form, backed by our normal kind of support construct. So you know if there's a PHP flaw, a Python flaw, a Ruby issue, we're going to patch it in those base container images, and they can auto update into your infrastructure. But you might decide that you know for your customers and your environment that you need to tweak the Red Hat supplied image and add some extra features, some extra security, some extra internal requirement. Well, then you can build that next layer into your pipeline and then have it so that the developers in your organization can consume your base image. But that's still being auto refreshed off the one from Red Hat. But it's an automated process. There isn't an infrastructure operations overhead every time we release a new security patch. It flows through automatically. Potentially gated, validated, checkpoints in the organization, but we want to make sure that as much of the whole process is automated.
And is that a single container that's being augmented, or is that a base container with another container running over the top?
Well, containers layer. So the container image you actually get from Red Hat, say, for example, it's Apache container. It's just got HTTPD. If you look at that container image, it's actually our base RHEL 7 image with the HTTPD and other components installed as the next layer. So everything we ship is based off our base RHEL image. Therefore, you get benefit from that commonality in that every image you're deploying is based off a common baseline. We try and maintain as many common layers as possible through the image stream because that gives you the efficiency of scale that you need from a container footprint. When you generate your internal image, you just put a new layer over the top. And we're investing heavily in those image generation tools to make the image generation more secure, faster, and smaller. If you want some more info on that, we've got a whole separate deck we can go through.
So this is one of the actual builds that you saw on one of my servers. They actually came from this template here, and so this is just a longer template. So there's lots of objects in there, lots of things. So this one automatically builds up the pipelines. You can also pass parameters in into it as well, and you can put Groovy script in there as well. Here's my Jenkins file that's inside of it. So templates can be, this big or this big, depending on really what you want to do with them, and you can do a lot. So as I was going to show you later, I can build a whole stack based on some templates. So yeah, so what I personally go, oh my God, look how much how am I supposed to start, right? So if you want to do have this idea where you've got these templates, you can, like you said, build it use the web interface, use the command line and build your kind of something to start from, and then you can export that as a template. So all of the objects that you've got in that application, you can actually export that as a template and then you have them. Are there any questions online?
Nope.
Nope. Okay, cool. So let me go here, and I'm just going to, for this particular example, yeah, okay, yeah. I'm just going to show you doing this in doing the template. So I'm going to do a bunch of stuff all on the command line.
If any of the
Paste.
terms Mandy Shea seem familiar, that's because a lot of them are based off Kubernetes as the underlying technology of OpenShift.
So right now I'm on the standalone Amazon box, and I'm going to create my new project, and then I have created just an environment variable to form for this particular template file. I'm just going to pass, and this happens to be on my local machine, but this could easily be one of the YAML files, the templates from GitHub. I tell OpenShift to process that file, passing it in some variables. So these are database variables, and then create from the output of that processed file. So remember, in there's a whole bunch of different objects. So from the output of that, just process everything and create it. Push enter, and just get the right screen. This is one. So view all projects, and I should have my new project here. There it is. Now, this, so all of that basically happened from that YAML file, that template file. This particular application is a Wildfly Swarm app, and it's a microservice for inventory. So this forms part of a larger application, which is the one that I was going to show you at the end. All it does basically is goes to the database in the back end and gets the inventory count for a shop. So all I did, I just deployed just that one microservice from that template file. If I added that into a bunch of others, you could see how you could have a template which could in fact deploy the whole shop. Easy?
Easy as.
Easy as, yeah. You can also create config maps from files as well. So do you guys know what config maps are? They're just yeah.
Yeah, we'll do a quick explanation.
Oh yeah, they're just basically a configuration file within OpenShift for that container. It's kind of mounted separate to the builder image, and it has a whole bunch of configuration for the app.
It's just a way so you don't have to bake your configuration files into your images.
And that's one beauty of that container ecosystem, is that separation of the immutable image from your either ephemeral or persistent storage, depending on whether it's a system or record or a short-term workload, and that configuration, which you can put through that config map or another source. And therefore, you can reuse the same container through your entire life cycle by just injecting different configuration data.
Yep. Okay, so.
And how do you deal with environment passwords in that scenario?
So as an environment variables, different
Environment passwords, so your container will need to have
confidential secrets.
Yeah. So we have we also have secrets as well. So we have config maps, environment variables, and secrets. Yeah.
And depending on the environment you're deploying onto, there's several ways of integrating. Like if you're deploying onto Azure, you can use Azure Vault as a secret store. Same on AWS, whether you're using OpenStack or VMware or other infrastructure, you can plug in a number of Vault-type platforms to actually hold those secrets.
Like I said before, OpenShift comes with a bunch of templates that are already in there, and I just did a get templates to to list all the ones that were installed. Now, if you'd actually put in some custom ones, those would come up as well. And I'll just...
And don't feel it restricts you to purely Red Hat technologies. Ultimately, this is a container runtime engine. Today, out the box, anything that ships as a container, you can pretty much run on OpenShift. And as part of the OpenShift roadmap, we'll shortly be supporting Windows native containers as well.
So I can, this is not obviously it's printed in a much neater way, so it's more readable. So I can actually just get the describe, use OC describe to print out what's all in the template. So again, there's ways there to help you build your own. You don't have to be building these, but it's just if you want to. And it is a really good way to be able to have this reusable and everything as code, containers as code idea within your organization. Cool. Okay. So, so that application that I just added in the inventory file that I just added into here, who uses Maven or any Java people? Okay, this is for you. Now I actually can't run it on my machine, so we have my special guest from Ireland. He's Irish, isn't he? Yes, from Ireland, prepared this for me. So if you have OpenShift and you are developing and you're using Maven, there's a Maven plugin, Fabricate, which will mean that from your IDE you can actually build and deploy your code straight from your IDE onto an OpenShift cluster. So it's another.
Anything for Gradle as well?
Oh no. So some customers do use Gradle, but we don't have. It's not supported at this point. We don't have but some people do use that. But your Mavens are. I have heard a rumor that perhaps a plugin for Gradle might be in the works, but that's kind of was really just a rumor.
OpenShift's got quite a vibrant open source ecosystem, so there's a lot of work going on around the edges where people have got stuff out there in the community. And the other one at the moment that's really interesting is that Microsoft's done a lot of work integrating OpenShift into all of its development tools.
Yeah. Right, so I'll just play this. It is, I think, 8 minutes long.
Okay, Maven plugin.
Can you use
We're going to use with our Wildfly Swarm development environment to build our
Maybe a little louder.
application locally and use the binary version source to image process to create a new image on our OpenShift cluster representing our application, our microservices application here. The Fabricate Maven plugin uses, as you would expect, it uses a Maven plugin under the profile OpenShift in our case here. Just contains some normal Maven identifying information like that group ID, artifact ID, and version. It attaches to these goals, the resource and the build goals. It contains some information here like the from Wildfly Swarm tag, which basically is going to be the image, the base image on OpenShift, onto which we will build our application to create our final application image using the source to image process, which obviously takes an underlying base image, being this one here, and then overlays our application on top. So let's demonstrate this in action. So here we can see our OpenShift cluster, and we've just got a few commands that are lined up. First of all, we have logged into the OpenShift cluster here inside of our terminal window. using OC login. And the Fabricate Maven plugin will use our local cube context to deploy onto whatever OpenShift cluster we have logged into locally here from our machine. So using our command line, we're going to first of all create a new project representing our Wildfly Swarm project. It's going to create a new project over here on our OpenShift cluster.
Now this is back in time because that's the one we saw earlier. We already seen it.
Created here. This particular application uses a database, a Postgres database, and we're about to create this database within our OpenShift project. Now we're going to create a config map from the project default YAML here to hold some identification information like the URL and the credentials that the application is going to use to log into the database. And the final thing we're going to do is using our Fabricate Maven plugin, we're going to build our application and then deploy that onto our OpenShift cluster. So let's go ahead. First of all, I'm just going to set my local identifier representing my Maven project. First thing I'm going to do is create my Postgres database. You can see that we created from this YAML file here, which just has some information around, this is a template, which is a cumulative OpenShift object representing various objects underneath it, such as services, deployment configs, they're the main elements that are in here, but the template contains multiple objects. So we've actually created that. And in that 2 seconds that we waited there, it's created our database for us. And it's deployed it, and now it's ready. Next thing we're going to do is create our config map. Again, using our OC local command line tool. And that's successfully created our config map. We look under our resources, config map, see that it's created it there. And as I mentioned, the main thing that is of interest here is the connectivity information that would allow the application to connect through to our new database. The final thing we want to do is we're going to create the application itself using our Wildfly Swarm local application. As I mentioned, we're going to build it first of all, and then it's going to deploy that onto our OpenShift cluster. So building the WAR file, it builds the jar file locally. It actually uses the jar file to deploy that onto the server. And it's using the S2I, the source to image process.
And these are really fun to do for hotel Wi-Fi.
Here's the build. This, in my case, is going to take quite a few minutes as I've got slow internet connection.
Yeah, it's in the office, it's in your mobile office.
It's going to copy it across, and then it's just going to pull that image into my application. So I'm going to pause the recording, and I'll show you the final completion when it's done.
A few minutes later, the Maven Fabricate build is completed successfully. As you can see, it's deployed the application onto my OpenShift running at this address here on AWS. You can see that it's fully functioning. Hit the URL, add a valid path, it returns to JSON successfully. So just to summarize what the
Fabricate will do, it allows us to, after testing locally in our IDE, to test out our application on OpenShift before even committing to source control to make sure that it's wired together correctly in OpenShift, for example, that the configurations that we apply in our various config elements are actually working within OpenShift. It also allows us to configure various elements that are various artifacts that are part of the configuration. One example being the config, deployment config, that basically describes how this application should be deployed. So for example, you can see here on the screen that inside of my IDE, I have a deployment YAML where I've specified a Liveness probe. This is a probe that OpenShift uses on a continual basis to make sure that the probe, that this application or deployment is still alive. It hits this path here, and if it returns a non-200 or 2x response, that will be an indication that the application, the pod, is no longer working, and OpenShift will not send requests to that. So this is a thing that we configure, and you can see that we configure it from our IDE inside our source name fabricate deployment YAML, and you can see that the end result is an identical element within the deployment console on the server. So that's a very brief overview of the fabricate name plugin and its usage with OpenShift.
So the funny bit of that is that when he paused it, he actually paused it overnight. It only took 2 minutes 37, but he started it quite late last night for me, so he paused it and finished it off this morning. But the marvels of technology, it was like blink of an eye. So that I know I've used that as well with a lot of Java, developing in Java, and actually then being able to push directly to an OpenShift cluster. I think sometimes, I think, this is just my personal opinion, is that you kind of, even though you can test your code independently, you kind of actually need to see it running as a container, so independently it works, but you should also be, unit testing or checking it within the container, right? And if you start, I don't know if you're in your organizations, you have DevOps configuration people who are responsible for like the running of the containers, or they're the ones thinking about liveness probes and all that kind of stuff, or it's the developer's responsibility. But to be able to easily deploy that onto OpenShift, onto the container platform, without having to think about all of those, the building elements and all of that kind of stuff, to be able to do that quite quickly, to be able to check it running as a container, I think is quite valuable. I don't know, that's my opinion anyway. You should always test it as a container before you check it in.
Well, it's a question of fidelity, right? How close are you to the actual environment it'll be running in production? And like, even you can argue like Minishift is great and everything, but nonetheless, it's still on your laptop. It's not in the final place where it's in it.
Yeah. There's
a lot of abstraction there, and a lot of things are the same, but nonetheless, it's still your laptop. It's not where it's actually going to run.
Yeah. Okay, so we've talked about building. So if you want to build your own templates, think from the bottom up. What's your base image? How's it going to be built? Where what images are going to produce? How's that going to be deployed? And then the other things on top of that you need, like network, storage, security, etc. If you want to build your own. We talked about the Maven 8 plugin. Okay, health and scaling. So I showed you already the idea that if you have a pod that dies, it will automatically be created again. But the other thing that we have is this idea of automatically scaling up and automatically scaling down when so if there's, say, for example, lots of traffic all of a sudden and you need to automatically scale up the number of pods to process that. So I'm going to show you that. And that one we are going to do on my RHPDS system because we use metrics for that. So I have metrics configured in here. Let me get, here we go. Okay, so just to make things fast, this is a Spring app. So this is truly a polyglot presentation. And I'm already running, so copy. So this is a Spring app. All it is just a little API that has some flight information. It just presents flight information back onto the screen. Just make sure I'm on the correct OC status. Make sure I'm logged into the correct system. So that is that one. OC status. I think I'm logged into both on the same ones. Yep, so OC log out. And I'm going to log into the RHPDS, the demo system. And I'm doing this all here just because it's easy for me to do it straight on the command line. You can do all of this in the GUI if you want to. And I am doing the new app, which I showed you before. So that will do source to image. It has JDK, and the GitHub is the Spring application. So that has started for me. And I'm also going to expose a service called Spring Boot. That's just the name of the service. It just coincidentally the same build technology. Okay, so here it is, and that is still building. So you see in this example, actually, sometimes like the route obviously came up first while the build is still happening. So it sometimes can take a little while to fork the repository. So that's forked that, and now it's building up that Spring Boot container. So this is happening within a builder pod. So the source to image process has automatically created a builder pod to process that. It's automatically done it. That's running, and then once it's finished doing the building, and then it will do the deployment, and this guy will come down.
When you're doing this at scale, think of a customer's environment where they've got real workloads happening over here. You don't want ad hoc builds impacting on that. So again, we can isolate selected compute resources just to be dedicated to doing builds. Or even some customers now have it so that the actual compute resource for building environments itself is elastic. So they spin up additional VMs or resources to provide that with more build resource if we've got a major deployment happening, and then scale it back down again. Meanwhile, the actual application workloads over here aren't being impacted by the fact that you've got many tens, hundreds, thousands of builds happening in parallel.
So that's all finished, and I'll just give it a little quick test. Oh, it hasn't started yet. Oh, now where am I? There we go. Just had to wait a moment. So we were talking about liveness and readiness probes before. So that was actually a really good example of the pod being up. And so on my console, it said 1, it's running, like it physically was running, but it was not ready to receive traffic. And so that's why I got that first error message. So if that was a live, real situation, obviously you would want to know if the application is not accepting traffic. So that's where the liveness and readiness probes come into it. So a liveness probe just saying, yeah, I'm up. A readiness saying, yes, I'm up and I'm actually receiving traffic. So a lot of these default, you put those into your configuration. Obviously, they're really, really important for your production ones. And then I would actually, I would have been able to see that it was not really ready for traffic yet. It was up. Okay, so I'm going to use these stats here, average over the last 15 minutes. These are the metrics. When you do OC cluster up or Minishift, you don't get metrics by default. It's another, you have to push that in because there's a whole bunch of stuff that goes on the background to add metrics. So what I'm going to do in this case is I'm going to modify my deployment config to a certain CPU target, automatically increase the number of pods that I'm running. Again, I could have all of this information in the template files if I want to do this, but I'm just going to show you this all from here. So configuration, add autoscaler. And my minimum number of pods running will be 1, maximum will be 10, and I'm going to set this down low. So CPU utilization of 20%. Okay, so now this has a auto scaling. I'll go back to overview. And I'm using JMeter to do this. Now for the Java people in the room, don't laugh at me, but JMeter uses a lot of resources, so it's actually going to give me an out of memory. It's going to give me an out of memory error, which I keep trying to set the right size to actually fix it. But yeah, see, there it goes straight away. I can't seem to set the heap right, so I just leave it erroring because it still works for my purposes. Okay. So right now, what the JMeter is doing is just firing a bunch of requests. And because I have metrics there and I have the autoscaler, so there's a bunch of things going on in the background that's monitoring all that traffic. And right, so now go back here. It's going to automatically scale up to 6. It's going to take a little time because it's got to actually work out that it's hitting the maximum, and then it's going to scale up. And I might actually kick it off and run it again, because sometimes because it has the errors, I have to run it a second time. You guys can tell me afterwards what I have to set so that it won't do that error. Okay, cool. So it's running some now. And it's auto-scaled already out to 4 pods. So I don't have to do that. It just did it auto-magically. Cool. And then so now the traffic has stopped. It doesn't just automatically drop down again because, I had the spike in traffic, so it scaled up. The traffic's dropping, but it's got to have a little bit of time before it goes, okay, the traffic has really dropped now before I roll them back down again. So that will take a little time. It's not too bad. It's a few minutes, but very cool. So you can also do things like you can use other automation to scale up automatically during time periods. I know one of our customers had their peak hours is between 7 and 9. Actually, I think a lot of customers' peak hours is between 7 and 9 on web interfaces because that's when people come home and finish dinner and they get on the internet and they do stuff like banking or whatever. And so they actually need to scale up. They scale up at that time, then scale back down again to save on resources and stuff like that. Anyway, so you can do that. Cool. And so that's that one. So next little one.
Sorry, just a quick question.
Yeah.
What component, when you auto scale, what component decides which request goes to which pod?
Say that again, sorry?
So you've got multiple pods.
Yeah.
So you have requests.
Yeah.
And you receive a request.
Yeah.
What component out of what you've built decides which request?
So Openshift. Because, so if we actually look at this picture, there's a good segue into the next discussion. So Openshift handles all of the routing. So it handles all of the load balancing between the pods. So once you are into Openshift, so once you have hit that URL and you're coming to the Openshift application, it handles how it directs the traffic.
Can you configure that?
Configure it as in change how it, yeah. So I'm going to show you that here. But a question for you. So what do you think would be the default routing strategy if you're running 10 pods? Do you think it would be round robin or random? Which would be the best way of routing? Which would be the optimal way? Hands up for round robin. Hands up for random. Who said random?
You should get somebody been asking lots of questions.
Wow, how's that for throwing, man? That's my time in Canada playing baseball. So, what is it? Bounce it. It sparkles. You can always come and swap it if you would like. You can swap it for a can opener. But I can't throw a can opener quite the same.
Well, yeah, could have implications.
But you can come and swap. So bizarrely, right? I actually don't know why it is this way. Oh, there you go.
That's my guess anyway.
Well, Google actually did massive tests on it. So the default strategy used to be round robin, and then Google did tests and discovered that actually the optimum strategy is random. And so now the default strategy is random.
Is it random different from least connection count, or?
I don't know. Would disconnection count?
Least connection?
Oh, least connection. Yes, it is. Yeah.
And if you're doing this at real scale, you can integrate with external load balancers and firewalls. It's still effectively managed out of the Openshift configuration because you tell it that you're going to integrate with this external load balancer, and then the actual load balancing requests are handed off somewhere else. And you can leverage existing large-scale infrastructure. But often, you may not need this until the last phases of deployment model. You may have an initial dev and test Openshift farm, you may have a staging farm and a production farm, but only when you get out to later stages may you actually look at integrating with expensive firewalls and load balancers. So customers do it many different ways. If you want to talk to us about any large-scale strategies, there's some amazing presentations people like Amadeus and Cisco have done at some of the recent Openshift Commons events. And we're talking here of tens or hundreds of thousands of pods.
So the question about controlling the traffic. So like I said, that you can by the way set it to be round robin as your default routing, but we support the it's very easy to do split traffic routing, so things like AB or Bluegreen or other strategies like Canary or etc. So I'm going to show you AB and Bluegreen, and I'm also going to show you a Bluegreen through a Jenkins pipeline. So that's like the last of our 3 as code things, the pipelines. So with AB, you can do this again at the command line. You can do it on the interface. I'm going to show you on the interface because it's like really super easy. And basically I'm saying, I want a percentage. I've got 2 services, and these are the 2 services that I created earlier, which are, let me go to the right console here and go to Mandy's demos. The 2 services, 2 applications are my cats and my cities. How we do this very easily, go to routes. I'm always forgetting where things are and I have to go to the different menus. Okay, so at the moment I have 2 routes. I have a route that will go to my cities version of the app and a route that will go to my cats version of the app. Remember, it's cats at the moment, not pets, because I put that environment variable in to make it cats. So if in a I can change this route. So because these are, so a service is basically an application with a port on top of it. What? Oh, I thought you were going to talk about the strategy. You had found the answer. No. I like your answer though. So a service is basically an application with a port that it's listening on, and the route is then that external address to go to that service. So this route here, my application, so this is the one that is cats at the moment, Canberra cat. Okay, I can go into this route, and let's just say I would like to actually send some of the traffic to cities and some of the traffic to cats. I can go on here and do split trafficking across multiple services. Because these are all within my namespace, which is Mandy's demos. The list of possible services is there, default 50/50. I can use my slider to change that if I want, but I'll just use 50/50 to start with and save. And so now when I go to that URL, half of the time I'm going to end up on cities and half the time I'm going to end up on cats. Let's just make sure it's exactly 50. So the other thing that you can do in Openshift as well on the web interface is I can actually edit the YAML directly here. Now, obviously, if all that stuff was in source control and I was editing YAML files, it wouldn't be updating in source control. That's what you would use something like Eclipse for if you wanted to get real fancy.
You can even drop a shell inside your live container if you're doing some troubleshooting.
Now, the trick with that with that route is it's really, really hard to show on the web interface. And in fact, I have to actually show you it on a different app. So what I'm going to use is a curl command to go 50% to there and 50% to there. And to make it really easy, I'm actually going to annotate that on a application that just shows me a blue circle and a green circle. So just 1 second, I'm just going to kick those off.
Under the hood, it's using HA proxy to manage those routes. So the traffic hits HA proxy and it's making the decision and managing the traffic out. So it can handle most services that support SNI and standard ports and so forth. We've got plenty of customers now looking at SDN integration for doing more complex things. But there's other ways of exposing other non-standard services out through Openshift. So there's a whole load of guides in the documentation if you've got your random services. And, I mean, this whole ecosystem is evolving at a very, very high rate of change. So start looking at things like service mesh and Istio as another way of managing large-scale complex services.
So these were the two apps that I was talking about, blue and green. This is what, remember I said something will go wrong? This is the weird, this is the something that doesn't look right. So that's very strange. The URL is exactly the same. Open a new window.
Oh, one's blue and one's green. Oh, no, blue green.
Don't they have to be the same URL?
No,
You know
at the
what?
moment they should be two different.
I don't even know how that even managed to happen. That is kind of crazy. Just, oh, I know why it's happened. It's all right. It's all right. I understand why it's happened. Because
You got your blue and your green.
yeah. I got my, so at the moment I've got my two routes here. I've got so I've got a green route and a blue route, and this blue route is going to blue, and the green is going to green. So if I go to this one, I should see a green circle, and if I go to this one, I should see a blue circle. And the reason why the console is showing me that is because I think it's because I have two going to the same server. Anyway, so this route here, this one here, is a main route that so it doesn't have any particular, like at the moment it's blue, right? So if I was just doing, if I wanted to do like a canary, or I just wanted to quickly check using the other service, all I need to do is actually change this route and tell it to, instead of pointing to the blue service, I can go to the green service. So it will do green instead. So now if I go, I'll just close these so I don't confuse myself. So now if I go to this one, where it was blue before, it's now green. Now, if I want to do, I'll just put that annotation on there again. So I'll go edit, onto blue-green, split the traffic. So at the moment, the service goes to green, I'll have it go to blue, and at 50-50, save. And so now half the time it's going to go to blue and half the time it's going to go to green. So I'm going to show you that, I'm going to prove that to you by doing a curl command. And just need to make sure I'm curling the right link. Is that the right link? Yes. Alrighty, so yay! Woohoo!
Otherwise, you hit the typical kind of sticky session issues with the load balancer.
Yeah. Now I can do, obviously 50-50 was a nice one, but if I want to, let's just change it just for the sake of showing that we can do something like that. Save. So you can kind of easily start doing some different deployment strategies. So now I'm going to go to blue more than I go to green. About, was it 1 in 10? I'm not sure how small I put that. 18%. Yeah. So perfect. Okay. So that's one kind of strategy. So the A/B testing, so for testing, you could also use that kind of idea for Canary. But you can see how it was really easy to do that, and you can build that into your pipelines. So because you can do all of that with the API, so all of that can be done on the command line, all of it can be done with the API, that means you can integrate that into your pipelines. So whether you are using Jenkins like Bamboo, or who use everyone for Jenkins?
Any other tooling?
Bamboo, Microsoft. Any Microsoft people in the room? That's cool to feel. You're good. Oh, I'm sure. You know what? I need a little
I'll
little
tell you my Microsoft story in a minute.
I'm missing the little penguin.
Microsoft
So I was going to point it out on the slide earlier, but in one of the first slides there was it talked about Openshift being able to manage like Linux containers, but actually we'll be able to handle Windows containers. So in an iteration of Openshift coming out soon, we will be able to natively manage Windows containers running on Windows servers, just like we look after RHEL hosts as the infrastructure. So that's pretty cool. That's going to be really exciting, I think. So yeah, Microsoft loves Linux. Okay, blue-green. So same different kind of strategy, blue-green. Everyone knows what blue-green is? Cool. So the idea that you have two services and both of them essentially alive, but you route traffic to one, means that if you need to roll back from that, it's very easy. You can roll back. So I did that in Openshift. I did that by having the main route, and my main route pointed to a service. But I also had access to the blue circle and the green circle independently as well. So I could still go to those if I use their direct route. But my main route, which is the one that everyone would use in production, so all the customers would actually come to that route, I just change it over to the new one. And if that one is right, I could keep that or I could roll it back. So it makes it very easy. And my pipeline example is going to do just that. When I'm testing out whether cities or cats, do I really want cities? Do I really want cats, right?
One of our large customers in Australia has got it so that they've done some smart routing so that their internal staff always use their staging environment.
I've got that slide.
You've got that slide. I preempted you.
You preempted my slide.
Cool story.
It is a very cool story. Okay, so I'm going to do this on my cat application. And so let's go back there. So Mandy's demos. Let's see if we're all set up.
Should have reread your deck. Should have reread your deck.
Okay, so I've got my application. Why is this? I don't understand. Okay.
You just changed it.
That is really weird. Okay, so I have my application cities, cool, and my application Here, cool. Now I'm going to create another route called main.
How are we doing for time?
I've got heaps of time. You'll just be squished.
We'll have, it'll be pizza and drinks at 5 o'clock.
Right.
How much more time do you think in your?
Not much.
Okay.
I've just got to do the pipelines.
Cool. Yeah, and that's great stuff.
Yeah. Okay. I want to be into, where am I? OC project, Mandy's demo. You know, I got on the plane, right? Mandy's not a particularly common name. I got on the plane and the one host said to the other host, "How's Mandy doing?" I was like, whoa, that is bizarre. He was talking about someone else, like another host that was called Mandy. I was like, what happened right as I was there? It's really freaky. Okie dokie. So I will create a new service. I digress slightly there. Okay. I almost left when I left. I was going to say, oh, say hi to Mandy for me. Thought that would freak them out. So I'm again doing that in command line, exposing a service. So OC expose service, my application name is main. And now that will create for me another route. Oh, hang on. Why has it done that? Where am I? I'm probably in the wrong cluster. No. OC project. Hang on 1 second. Why is that not working? Maybe I'll just do it from here instead. Routes. Create a route. Main. And that's going to go to my application, create. Cool. Okay, so now I have a main route, and that is pointing to my application, which at the moment is cats. Melbourne cat, she's a bit grumpy, looks grumpy. Auckland cat, this will be way cool. Yeah, cool. I totally didn't make these. So anyway, okay, so I can't look at cats all day long.
On my wife's though.
Okay, so I have the 3 routes against the main one and there. Now, if I just want to, I can simply change this route to point to cities. And now anyone who's actually going to that main one will be going to my city. So let's do that. Actions, edit, change that. So very, very easy. And all of this can be done in the command line. All of this can be added into your build pipelines. And in fact, it will be. So now I have Adelaide. Cool. Easy to just pass things in the command line. Here we go. Wellington. Yay.
Hey, you can see us.
Hey, you know what? We'd be somewhere here, aren't we? Nowhere. Somewhere here? Huh?
Oh, that's an older photo.
Yeah.
Yeah. So just being rebuilt.
Yeah.
Did anyone see the very amazing?
For a while.
Yeah. There was a rainbow here this morning. This is what I don't understand. I think it must be a GUI thing. Okay, right, cities. Okay, now. So Bluegreen deployments, super easy. Yep. Okay, OpenShift loves CI/CD. So Jenkins. So we know that this is like the crucial part of being able to automate your application deployment. OpenShift was not Kubernetes, and then we went Kubernetes is it. Kubernetes is the bomb, and we went all in on Kubernetes. We chose Jenkins as the CI/CD tooling. We have tightly integrated with Jenkins. So all of the integrations that we've got within the API are all for Jenkins. That does not mean that you can't use another CI/CD tooling like Bamboo or something else, right? But we've got a lot of plugins, and the integration is so tight with Jenkins, right? You have to do all of that work yourself if you're using another tool, which you can do. It's just that you have to do the hard work. We've done the hard work on Jenkins. And at the time, and I think still is at the time, Jenkins was the tool of choice. So, okay, what's my next slide? So, by integration, one of the things is that you can actually see the pipelines running within the Openshift console. And when I add a pipeline into my application, it will automatically, in this case, it automatically actually runs Jenkins for me, and it will run a Jenkins within my project. So some customers we have use that. So for individual CI/CD testing and pipeline kind of processes for the developer themselves, they have their own individual Jenkins, but then they use a. How did that happen?
Yeah, I'm not sure what to put that.
Sorry?
Oh, it's when you answer.
Oh, it's automatic. But they use a master Jenkins and sometimes use Jenkins slaves, run Jenkins slaves in OpenShift. They'll usually have like a centralized Jenkins. But so we have single sign-on to Jenkins as well. So this is more what I mean about being tightly integrated. So what do you put in your pipelines? What do pipelines do? In my case, I have a simple one that's going to do that blue-green rolling deployment. Usually what people are using pipelines for is moving code through to production, right? So you can put everything and anything in your pipelines, and you should. So all of your automatic testing, promoting and tagging your images through environments, and of course you can also put manual steps in there as well. So one build deployed many times through the environments being promoted by Jenkins as it's doing automatic testing. All of this stuff here can all happen automatically, but then, as in most cases, even though, you know, if you read the Phoenix project or one of those, the idea is push the button and it goes all the way to production. Most enterprises, that's never ever going to happen, right? So put those stops in your pipelines to say, right, we need an OK now before we can promote to production, and that's what my example does. Right, sometimes you might already have your own, or you can still use your own source control processes, just then augment that with the OpenShift delivery process. So all good. You just may have to do more work. This is what Steve was talking about before. So right, I am going to show you the pipelines example. Cool, you still with me?
Mm-hmm.
Yep, second to last example.
And then beer and pizza.
Is it beer and pizza time? Oh yeah, it is.
We're getting there.
Oh, cool. Okay, so second to last example. I'm going to be in my, hang on, I don't want to be in that project. I want to be in this project here. So my pipeline is on GitHub. It's called main. I need to have, I've got a service called main, I've got a service called my application cities, and I've got a service called my application. So everything I need. I'm just going to delete any old previous pipelines that might be hanging around, and I'm just going to make sure that I am on my AWS cluster. AWS, yes I am. So I'm just going to delete, and what project am I in? I'm in my Bluegreen project. Oops, sorry. I go over to my Mandy's demo space. Yeah, it's really loud. I'll just put that on mute again. Sorry. Why were on mute? Oh, maybe because the sound's going out that way. Anyway, okay. OC project Mandy's demo. Cool. You are not a member. Okay, I don't understand. No, it's not.
Oh, plural demos.
Mandy's. Oh, Thank you. I knew I was going to do that, so I need to make sure I was going backwards and forwards. Okay, so paste. So Mandy's demos. Here we go. I don't think I haven't got one there because I created this project here. So I'm just make sure that there's none. Cool. There's none previously. Okay. So I'm going to create this from a YAML file that's on source control. And that one. I've got all these source control windows open so that I could show it to you. Cat of the day, pipeline. So here's my pipeline. All this does is pretty simple. It will just say what service is that main application pointing to. It's pointing to cats. Okay, so I'm going to change that route and make it point to cities. And then I'm going to say, right, is that good? Would you like to keep that one? Yes or no? And I can abort it or roll it back. But so this is just a very simple pipeline. But you could put anything and everything in here, right? And you should, especially automated testing. Cool. Who writes these things?
Certain to.
Yeah. Yeah. You're going to be able to make Openshift sing. I think it's pretty cool, actually, that the amount of stuff that you can put in your pipelines. Okay, so what's it say now? It says something is forbidden. Developer cannot create build products and then cannot create build in Mandy's demos. Yeah. Okay. What have I done?
Well, the Mandy's demo, not that it should be demos plural.
Yeah, I'm in that project. So we have something went wrong.
In your pipeline code there, is the namespace the singular?
It is singular. You know what I'm going to do? Because it's going to be easier, go and change it. It is singular in my pipeline. So I'll go back to my source code. Mandy's demo, there we go. Edit, change it. Commit that, fixed. Namespace, issue, commit. Now earlier today I found that like sometimes the raw files take a little time too. They must cache somewhere on GitHub. So Mandy's demo, yeah. Mandy's demos. Okay, now let's hope that this is not getting it cached. Right, cool. Fingers crossed. No, it's still cached. I don't know how to flush it. Still cached. Would probably be just faster for me to create Mandy's demos. Do you know what?
Or just copy the whole file, copy the raw content into a local file.
Oh, yeah, I'll do that. Yeah. What I can do, actually, why don't I do this just before I show you that. Remember I was talking about RHPDS before? Yep. And services that I can create. So, log in. Catalogs. Services. Catalogs. Openshift demos. Multi-product environments. Okay, so this here is a template that has all of these things in it. So I can order this, provisioning time about 15 minutes. So I'll kick this off. This is going to go into this interface here. So this is on my demo system. And at the moment, I have this monolithic application. So Openshift isn't just for microservices. Openshift is for monoliths that you're strangling or monoliths that you're just keeping and running.
That you're hugging?
That you're hugging, yeah. We talk often about containers and microservices, but I think the reality is that microservices are hard, right? And so it's more likely to be mini services or monoliths that have been lifted and shifted. Okay, so this application, I'm just going to show you what it is. It's called our Cool Store application, and it's a shopping cart. It is actually a bunch of microservices. So there are two versions of this. We have a monolith version of it and a microservice version, and this is the microservice version. And we have a bunch of services. The inventory service, which we loaded with the YAML file earlier, a cart service, and a catalog service. Looks something like this. It is a polyglot application, so it has a mixture of there's EAP in there, there's Wildfly in there, there's not Wildfly, sorry, there's Fuse in there, Tomcat, so there's a bunch of stuff, different databases. I think there's Wildfly. Okay, I'm going to push the button on this to provision. So again, this is CloudForms. This is used Ansible and Openshift templates. This is all in source control. I will show you the GitHub as well.
CloudForms lets us take some of this automation up to the next level. So you can provision services across different types of cloud providers, on-premise infrastructure, your traditional big fat mode 1 infrastructure, right the way out to containerized services.
And so what's different here is that I'm now taking an entire application. So one of our customers has this idea of bank in a box. They're not, they're an overseas customer. And they have this idea that a developer can provision an entire environment that has everything in it to have like a mini online bank, basically, so that they can test with. Right. So when we're talking about automation and self-service, this is kind of the pinnacle of that. So I'm just going to submit that, and we shall see. We'll actually start to see it will spin up containers and applications running into this platform. So I'm going to leave that running while we go back and try. Go. Yes. So how long was that? Like 5 minutes? Okay, cool. So now I have a pipeline over here. Builds pipelines. And I can actually see that pipeline. So I see the YAML in here. You can have this in source control with webhooks as well. So you can set it up such that when a pipeline changes, you can, and it's the same with the other source to image, the other applications that you've done, you can actually set up webhooks that say when I've gone and checked code into my GitHub or my Git repository. We're great with any source control system you want, especially if it's Git. So code goes in there, I've committed it, webhook triggers and says, right, it's changed, rebuild the image, redeploy. That can happen all automatically. Okay, pipeline. So let's play this pipeline. I'm just going to check my applications. So when I loaded that pipeline, it automatically set up Jenkins for me. So that all happened automatically. So that was all part of the whole pipeline creation process that is happening within Openshift. Cool. Okay. Now run the pipeline. Start pipeline.
When it comes to those webhooks, is it easy enough or straightforward enough to actually kick off builds from pull requests? So it actually kicks off the pipeline from a pull request?
Yeah.
Yeah. Oh, look,
That's
failure.
very common.
Failure. Deploy test failed. that wasn't supposed to happen, but I just made it sound like it was, right? Okay, so I can go, and now sometimes that happens, it's probably because I changed this pipeline earlier, which we know we shouldn't do, right? So I'm gonna go and look at the log and see what it is. It's probably in another Mandy's demo. So Jenkins, we have single sign-on with Jenkins and Openshift. That's using Red Hat's single sign-on application. Now, for those of you who use Jenkins would be familiar with this horrible looking interface. Okay, so what happened here? Mandy's demos from project, providing latest deployment. Have you guys used Jenkins, used Blue Ocean? Yeah, looks much prettier. So, there. Why that was.
That one mine failed earlier. It was just internet lag.
That failed for some reason. The build. So I'll just sometimes you just run the pipeline again. I'll start again. And fingers crossed. I have to do a toast, don't I, to the demo.
Sacrifice. When you say anything about triggers, that's really common. Whatever your source code platform is, on a given branch or whatever you want your rules to be, is have it auto trigger builds, push it through, give a test framework, gate it as far as you want through your environment.
Mm-hmm.
If this doesn't work, I'm just going to because these are like honeybees, right? Like worker bees. I can just get rid of a few and make some more. So I can just like delete them and just rebuild the application because we can rebuild. Right, while I'm waiting on that, over here, we now have a whole bunch. So this is my RHPDF system that I ordered the application on. And so I now have a whole bunch of new projects that have been created. So I have the CI/CD project here, which has a bunch of infrastructure in it, including a GOG server, guides. Now this is actually the guides for running the demo, Jenkins server, and
GOGS is a GitHub clone type thing.
Yeah. In production, I have the cart service, the catalog service. I've got a gateway service. I've got Hystrix service. I've got a bunch of the inventory, and all of this has all been created from that template. So all of this automatically just created. And if I go over to the web interface, web UI. Still running, like I said before, this will be still coming up. So I will just leave that up. Here we go. Look, it's still coming. Is it 15 minutes yet? Not quite, eh? Cool. Okay. Let me see. This is still building. Okay. Let me see if I can figure out what's going on here. Any questions while I just trash my application and start it again? Did you have a question? No? Okay. I'm going to delete my app, delete my demo and start it again.
So while Mandy's doing that, recently we did a joint session with Microsoft showing SQL Server running on Linux. And as part of those sessions, we actually demoed it running in a container on top of Openshift. So we basically on the fly created, or based off a standard RHEL image, installed, configured, and had Microsoft SQL Server up and running in a couple of minutes. Once that container was built, you could deploy it, as many times as you like within your organization, because you're just injecting, configuration and providing some storage. What was really neat was Ansible was like a lifesaver when we were doing those demos, because we came up with an Ansible playbook that rebuilt the entire Openshift environment we were using for doing the demos. So if we had a problem, and I had one when I was going to present in Auckland where the environment had crashed and burned because I'd run the demo that many times, I'd actually used up all the storage on my virtual machine. Instead of troubleshooting it, while I walked on stage, I deleted it, created a new stub virtual machine, kicked off the playbook, and while we were going through the slides, it built, installed, configured OpenShift, pulled down the playbooks to build Microsoft SQL Server, and then I was ready to go and do the demo without anybody in the audience realizing that the whole environment had been built from scratch while we were talking. And that was over the hotel's Wi-Fi connection, which was particularly impressive, because I managed to pull down a whole, it was just an OC cluster up small environment, but Ansible for us is such a lifesaver. Every time we want to go and do a demo, anytime we want to go and show anything to our customers. And at the end of my session, we'll show you some links, but when we're doing OpenShift at scale with customers, we actually use Ansible to deliver it. So we have a Red Hat developed in conjunction with the community set of Ansible playbooks for deploying OpenShift at scale, regardless of whether you're doing it on VMware, OpenStack, Azure, AWS, Red Hat virtualization. It doesn't really matter. You can optimize for a given footprint, and you can use the same playbooks for scaling that infrastructure as your workloads increase. And that's one of the beauties of that Ansible automation in conjunction with something like OpenShift. On the other side, we're now plugging Ansible in through the Ansible Service Broker into OpenShift. So if you're deploying a service that's a combination of your modern containerized workloads, but you want to go and consume some traditional database or some traditional on-premise service, then maybe you can use Ansible to provision that for you using Ansible's capabilities of going and creating a copy of an existing large-scale Mode 1 big fat heavy database platform because I need to go and reuse some existing production data for doing a test run. So you can use, these tools are being integrated quite closely now.
That project you created early on was...
I've changed the name.
Oh, you changed back to singular? Okay.
Yeah, good
Sure.
catch. Yeah, I did. Good catch though, because I wasn't sure if maybe I just needed to change it somewhere else as well, so I thought. So as Steve was so eloquently talking about Ansible and stuff, I'm still a little bit old school and using copy and paste. But I should Ansible it all, right? So I don't ever have to copy and paste.
Well, the funny thing about that is you kick off the Ansible and it does all the things and it's done and you get the end product and it's a beautiful end product. But when you don't understand the automation that goes into that Ansible, it's in some cases a little too magical. And for me anyway, I find it really valuable to go through the step-by-step thing and then either automate it myself or, oh, hey, here's the actual Ansible, or take the Ansible if it is all there and really dissect it and walk through the tasks so I understand exactly what it is it's doing.
So one of the URLs I'll include my slides is like both Mandy and myself, a lot of the artifacts we use are in our own GitHubs. So most of what you've seen today you can get access to and try out yourselves. If you're playing around with OC cluster up, often making sure you've got all the prerequisites sorted so that OC cluster up works properly on a baby Linux VM can be frustrating. The documentation isn't quite as clear as it could be. So that was one thing we did, is we just came up with an Ansible playbook that dealt with all the standard prerequisites, made sure those firewall holes were open, that the default networks were present, that the right base packages were present so that the next bit could go ahead, and then you can default back to the command line and go through and create the rest of your environment. You working?
Yep, Jenkins is just starting. So I just while we were talking, I just recreated those apps. And so now this will be pets again because I rebuilt, I deleted and rebuilt. And of course my environment variable, because I did that manually on here, right? So hence why doing everything within templates. So I quite like when we talk about this system here that has a full stack, Everett, to your point, it's like if you don't know the individual elements like that are making it up, it is lots of magic. Let's see if that's actually started now. Yep.
One of our colleagues develops quite a lot of our big global demos. He's got a very, very cool set of demos for deployment on top of Openshift. We did them once in a lab when we were over in Asia. It was quite interesting watching 30 people try and download 4.5 gig each in order to run the demo over a hotel Wi-Fi connection. You can imagine how well that went. So sometimes, yeah, you've got to make sure that you build the right learning curve for this. So get your hands dirty, understand a few of the moving parts, get to understand a few of the fundamentals.
Make things break.
And yeah, you've got to break things. If things never break, you never learn how to fix them.
Okay, Blue Ocean, go Blue Ocean. I'm actually trying to figure out how to make this the default. I can't find it. If any Jenkins experts in the room can tell me how I can set it up so that the default is Blue Ocean, I would love that. All right, so my pipeline's here already. I'm going to go start my pipeline. Yes, go gadget, go. Okay. Builds, pipelines. Everyone cross your fingers. It's going to work this time. Start.
Yeah, it's on its way up.
Sometimes when I start the pipeline too soon and not everything hasn't come up. Go build, go build, go build.
Yes, patience is interesting. We can do some of these things so quickly. OC Cluster Up is a great example. If you're playing with OpenShift, wanting to try things out, running it on your laptop, running it on a VM on your Mac. If you go and try and run it too quickly, you get tied up in knots. It's still starting.
No.
Yeah, you're all good.
I am good. Right. So this is the first
Gate.
Yeah. So my first gate. Lovely message. Okay, it says the build. So the default route, the main route, was pointing to my application, which was pets. And so it worked. The pipeline said, oh, what's the default route? Oh, it's pets. Okay, so I'm going to change it to cities. That's the new app. So it's now saying, do you want to, I've built it. Do you really want me to deploy it? So right now, exactly at this moment, main, this is still pets because I'm actually prompting for that input to say, yes, I do. I really want you to change it to cities. So I could say abort, in which case it would not make the change, or okay. I'll do okay. Now it's now I want to go have a look at it. Just want to make sure I'm not caching. Yay! Okay, so do we like cities? Do we like pets? What's the vote? Cities? Hands up for cities. Hands up for pets. Oh man, pets you lose, mate. Okay. So I am going to say keep. Yes, keep cities. Keep. If I said keep, there we go. If I said no, then it would have rolled back. So cities, don't make a liar out of me. Still be cities. Yes. Cool. Okay, and so yeah, look at that, all integrated, beautiful, lovely, very simple pipeline. And on the other side of that, it was within 15 minutes because I checked. We had this full shop. Now you can't really buy a Fedora off the shop, sorry, even if you download the GitHub repo and you install it yourself on your own OpenShift and put the ads, you can't buy the Fedora.
We're only allowed one extra.
The way you get a Fedora is you can get a Fedora if you come and work for us. That's how you get your Fedora. Alrighty, cool, awesome, love it. I love it. Okay, so I have to go backwards because I skipped something very important. So Steve was talking about one of our customers, Macquarie Bank. We quote them a lot, right? They have a special way that they do production. Hi. They have a special way that they do production. They release all their code in production, and they rebuild their production every 90 days. So at day 60, they start completely rebuilding their infrastructure. They rebuild, they do every single thing, all the networks, all of the infrastructure, all of the firewalls, everything is rebuilt. And they completely redeploy their production system. So they start with this version, and then they completely redeploy that. The other thing they do, if we look at this picture, is that they have different, in production, they have different environments, a different beta kind of environment. So they have a staff beta, they have a public beta, and they have a development area. So when they put up to this continuous deployment environment here, testers and developers, when they go to their banks, they go to their banking app, they route, so the magic API gateway there in the middle actually routes their traffic through this system. So basically, if you're a tester or a developer and you're going to your banking app on production, you're going through your test code, so it better be right. Yeah. So if you then there's also a staff beta. So there's a list of like staff. I think it's the majority of staff actually are on this, where the same thing happens. So this is kind of the next level on once it's gone through test. This is real production data. So it's not like just a little test system. This is real production. And then so they route staff through this beta one, and then there's a public beta which people have registered for to be on, and then it goes into production. So they have their idea of like continuous delivery is quite interesting, the way they do that, I think. So cool store, we've talked about that. Any other questions? It's great, eh? You just want to go OpenShifting now. Cool. Right, so I will just leave you with this lovely picture. So as I said earlier, your pipelines are kind of key. You can automate everything. There are so many layers of automation. Put everything as code, automate everything, and use pipelines to make OpenShift sing. Thank you.
Thank you. So I think we'll take, 15, 20 minutes to eat. Let's not make it too long because probably don't want to be here all night. And then we'll get back to. Oh, okay, cool. Yeah. So yeah, anywhere between 15 minutes, half hour, we'll have a bite.
Awesome. Great. If you haven't had any swag yet or want to swap swag, we've got our Red Hat bouncy balls, which please do not feed to your dog. They have batteries in it. You will not be responsible for your vet's bills or your. We've got some bottle openers. Yeah, it should work because it needs a second bounce quite. It doesn't bounce the first one. Take a bit more. Thanks for all the questions.
I don't like
My wife's stuck in the back, so she's also in town at the moment.
How's it going here? Good.
Well, I'm up next.
What's that? Nah,
That's all right. Or something.
pretty standard when it comes to demos and such. What are you gonna do?
Oh, some of my colleagues in Australia love video demos, and we're like, why? Let's get the fun in that.
Yeah.
We did well.
You were talking about that.
submitted there.
So can I pinch your side of the table?
Right, so what's